A square matrix A is an invertible if and only if it is non-singular. Option C is right one. So what is the meaning of invertible matrix? To understand this, first the very common invertible matrix is identity matrix. Identity matrix. This is invertible, or you can say non-singular. So both are same terminology. If and only if matrix is 1 1 and onto. Invertible matrices always 1 1 and onto. To check 1 1, suppose this is a matrix A B C D E F G H I J K L. Now normally we write matrix representation column wise. So for onto matrix or onto matrix representation, a matrix representation said to be onto if and only if it contains pivot in each row. For onto pivot in each row, and for 1 1 pivot in each column. For 1 1 pivot in each column. So this matrix is 4 cross 3. So you can consider a linear transformation going from R3 to R4 like this. When number of pivot in rows equals to 4, then matrix representation is onto. But what is the definition of 1 1? In linear algebra, or simply in terms of function, a function said to be 1 1 if x not equals to y, then f of x must not equals to f of y. So this is the definition of 1 1. But in linear algebra, you say tx equals to 0 if and only if x equals to 0. This is the definition of 1 1. A linear transformation is said to be 1 1 if it is satisfying tx equals to 0 if and only if x equals to 0. If we have matrix representation, then change t with a. So ax equals to 0 if and only if x equals to 0. So matrix representation, how we can easily tell matrix representation is 1 1. So if each column, suppose column 1, column 2, column 3, if each column contains pivot, pivot element, then ax equals to 0 in the case only when x equals to 0, because there is no free variable. No free variable. If there is some free variable, transformation cannot be 1 1. Transformation cannot be 1 1. But this is not our concern. Our concern is only about singular or invertible matrices. Option C is right one.